Now we're going to cover sketching a graph given key features. So let me start in advance by saying there's no right graph for each one of these kinds of problems. Your answer is correct as long as you have or stay in the guidelines of the key features given. Okay. So when I do these, I kind of like to make notes as I go along, starting with roots and solutions, right? Because that tells me where the graph is going to intersect the x-axis. So I see it -11. Be careful here, right? Because each square counts for 2 up, 2 down, 2 side to side. So 2, 4, 6, 8, 10, 12. So it'll be 11, or excuse me, -11 right there. And I personally like to write my coordinates when I make them. And then +15. So 10, 12, 14, 16. Split the difference. Okay, so again, I know these are my roots and or solutions. And again, my scale for this graph was a 2x2. The next thing I like to do is go in with my range. That tells me the smallest value to the largest value that my graph can cover. So the smallest y value that can hit my graph is -4. So it's going to cover this line right here. So as long as I have a dot anywhere along here, then my graph would be correct. Usually your min value or your max value, whichever one, is going to be in between your roots, so you'll have a turning point. So I'm just going to place it right here again, as long as it's anywhere on this, and you can draw the graph, then I can't, or nobody can question that you're right or wrong. So 2, -2, -4. Because this point, after I do my range, I then like to go into my end behavior. So left and then right. So as x goes to -infinity, y goes to +infinity. What this tells me, at the leftmost piece of my graph is pointing up. X goes to +infinity, y goes to +infinity. This tells me that I must have an arrow pointing up. To the left of my solution for the leftmost piece of my graph, and then on the right side of my right solution, it must also point up. Now the domain, -infinity to +infinity, so again, I have to have arrows. So last but not least, I finish up with my domain. And when you do all of these steps ahead, it kind of takes care of your domain. So then you just sketch your graph by kind of connecting everything that you've done up until this point. Again, just kind of make it close. So this graph would look something like this. I would caution you about, having it look like that, because then we would have 3 solutions or 4 solutions, right? So it doesn't say that it can't be there, but you kind of assume, and the less you assume in math, the better, unless you know by reasoning from prior topics or lessons that something is. For example, if it's got if you don't see a dot on a line, it's okay, because essentially a graph is a whole bunch of points right next to each other. So again, these aren't too bad. It lets you use your imagination. I'll save this last one for y'all. Again, if you have questions, email me.